last class, we have discussed how to define the grammar. Like for example, for assignment statement, we have defined like this. Assign gets to are defined to be ID equal to expression, and we said ID defines to be A or B or C. An expression defines to be ID plus expression, or ID into expression, or expression enclosed in parenthesis, or ID is it, right? Fine. Now let us take one statement, and we have tried to derive this statement using the grammar, right? So how we were deriving, we start with assign derives to be ID equal to expression. We said then A, in place of ID I have taken A equal to expression, and now expression is expanded with the definition of ID into expression here, right? ID into expression definition. Then A equal to, in place of this ID we have taken B in order to get this particular statement, into expression. Again, this expression has been expanded with this definition, expression enclosed in parentheses, right? This definition. Then A equal to B into, right? This within parentheses, this expression when being expanded, we have taken another definition of expression, that is ID plus expression, right? So then in place of ID, we have substituted A, and then expression is defined with ID, and ID gets to C, we said, right? Because ID can be A or B or C. That's how we could see we have derived this statement using this grammar, right? And we said this derivation is a leftmost derivation because you can see the state in this statement, you can find the identifiers from left onwards, right? Leftmost onwards. Fine. Now, let us draw the parse tree for the same, okay? Here I am trying to draw the parse tree for the same. Write down what is parse tree here. Hierarchical, syntactical structure of a sentence of a language is called parse tree. Or you can say hierarchical representation of derivation, right? Okay. For example, here you can see, one parse tree is, represented. So now we'll try to derive the parse tree for the derivation that we have seen here, right? So here, when I have to construct the parse tree for this particular derivation, how do I do? I'll start with the statement assign is derives to be ID equal to expression, right? So how do I write? Assign is my root, right? Basically tree, in tree there will be a special node called root, right? So this root is the node from where you start traversing the tree. This is your root, right? Assign. So this assign is expanded with ID equal to an expression, right? So this ID is being expanded or gets to with A, right? And you can say it is derived to be A here, right? Then this expression, I'm just going with the derivation directly, right? ID is derives to be A here, right? Then expression is expanded with ID into expression. The same I'm writing here. Expression is derives to be ID into expression, right? Then in the next step, this ID is derives to be B, and this expression is further expanded with parenthesis enclosed in expression. So open parenthesis expression and close parenthesis, right? And close parenthesis. Then this expression is now further derived to be id plus expression, right? Because here you can see in the derivation, this expression enclosed in parentheses derived to be id plus expression. The same statement here in order. Expression is derives to be id plus expression. Now id is further derived to be a. This id is derived to be a here, you can see, right? And then you have this expression derives to be id, right? So this expression is derived to be id here, right? And then this id is further derived to be, what do I need as per the statement? A plus c, right? So I write here, so expression is further derived to be id, and this id is further derived to be c. So you can see a equal to b into, within parenthesis, a plus c close parenthesis. So this is what my statement is, right? A equal to b into, within parenthesis, a plus c, which has been derived here with the help of this Parse tree, right? This is said to be the syntactical structure of a sentence of a language, right? Or hierarchical representation of tree. So generally, the grammar, when people define, the grammar should be in such a way that it should not let any statement to be derived with more than one parse tree. Fine. If a statement is let to be derived with more than one parse trees, then we say that grammar is ambiguous, right? A grammar is ambiguous if and only if it generates a sentential form that has two or more distinct parse trees. It means here you can see I got one tree, right? This is one tree which I have been able to construct, right? From this grammar, right? From this grammar. Can you be able to construct any other tree using the same grammar? No, because this grammar is unambiguous. If the grammar is ambiguous, then you will be able to construct more than one parse tree for a statement using that particular grammar. Okay, so the grammar using which you can generate more than one parse tree for any statement, that grammar is said to be ambiguous, right? Ambiguous grammar. So now, the language designers must ensure while designing the grammar that the grammar must be unambiguous. You can see here one example is given in the PPT. So here you can see expression in this. You can see expression is defined to be expression, operation, expression you have, right? Or constant. And this operation is defines to be either divide or minus, okay? So if I take one statement, if I take some statement, constant minus constant by constant, right? Then I will be able to derive two parse trees here, you can see, right? Constant minus constant by constant. Okay, let us take, this is the statement, okay, to be derived using this grammar, okay, using this grammar. Now, generally, how do you derive? You start with the start symbol of the grammar, expression. So expression is derived to be, in order to get this particular statement to be derived, you say expression is expanded with, you can see there are two definitions here for expression: operation, expression, or constant reset, right? So you take expression, operation, expression. Okay, you have taken this, and then this expression is divided, is expanded into expression, operation, expression. What? So now this expression is further derived into constant. I have taken another definition of the expression, that is constant here, right? So now constant here got. So in place of this operation, let us take minus in order to get minus here, since the minus is first here, and this expression is derived to be constant here. Okay, because I want to get a constant here, and for the expression I have another definition constant as well here. Now, in place of this operation, in order to get divide, I said I have taken divide. Divide is one of definition of operation, and minus is also another definition. I can take any of them, okay, for operation. But now, expression, for this expression, I have taken the definition as constant, not to get this. So I have got constant minus constant by constant. That's good. Now, using the same grammar, I can either derive the same statement in another way as well, where my tree is going to be differed from this particular tree. You can see here, expression, I have taken the first definition of expression as expression, operation, expression, this one, right? Then this expression I have not expanded, right? I'm not expanding this expression. So this expression is led to constant, is derived to be constant here, and this operation led to be derived as minus, and this expression on the right hand side now been expanded. Here I have expanded left hand side, whereas here in this, okay, I have expanded the right hand side. Okay, so expression is now derived to be expression, operation, expression, and this expression is derived to be constant, and this operation is derived to be divide, and this expression is derived to be constant. Now, tell me, are these two trees is same? Okay, these two are not same, right? These two are not same. They are different. Okay. Here you have this constant by constant operation will be carried out first. It means division will be taken out first, and this whole becomes the operand for this operation. Okay, it means minus. For minus, you will find one operand is constant, another operand is entire thing. So it means the operation will be now taken place in this particular tree is first the division. Okay, and after once the division operation takes place, then the minus will take place. Whereas in this particular tree, what happens is first the minus operation will take place, because this operation divide needs two operands. Right operand is constant anyway, left operand is this entire thing, right? So how we are going to get this entire thing is by being evaluated. How we are going to get it evaluated? This expression being evaluated with constant minus constant. It means here in this case, what is happening? First subtraction is being performed, and then division is being performed, right? Let us take one instance of this particular statement. If I go with 2 minus 8 by 4, if I have an instance of this particular statement is 2 minus 8 by 4, then what is the result if I am going with this particular past here, and what is the result if I am going with this particular past? Is it going to be the same? Check it out, right? Here in this case, what happens? First, the minus operation will take place. So 2 minus 8 is going to be minus 6 here, and then the division operation will take place. So minus 6 by 4. Getting the point? 2 minus 8 is minus 6. Minus 6 by 4 will give you what? 3 by 2 minus 1.5. Okay, that's good. Now coming to this, here you can see if I am evaluating 2 minus 8 by 4, right? So in this, if I am going with this particular tree, what could be the result for me? First division operation will take place. So 8 by 4 will give me 2, and 2 minus 2 will be what? 0. I'm going to get 0 here. Which one I should take? Shall I go with this result or with this result? Right? It means if I'm having grammar like this, right? Okay, when the LHS part is available on the RHS on both the operands of the operation, right? Okay, then the problem is coming, rather, right? This kind of grammar is said to be the ambiguous grammar, right? This kind of grammar is said to be ambiguous grammar because I am able to generate 2 or more than 2 sentential forms or parse trees are the derivations of a particular statement, right? So if I have multiple, parse trees, which one will be taken by the compiler to evaluate my statement? Okay, it means the compiler will be in a confusion which one I should take. Getting the point? So compiler should be given clear guidelines, right? The system should be given clear guidelines, right? So in order to have the unique, parse tree to be generated through the grammar for any statement, the grammar must be unambiguous. Unambiguous. It means the LHS part, this LHS part can be available for the recursion rules either on the left hand side of the operation as an operand or on the right hand side of the operand, right? So it means if I'm having this is also a recursion, right? When did I say the rule is recursion? When LHS part is available on the RHS part. This is recursion anyway. But then this is said to be two-way recursion because you can see this is the binary operation. So binary operation requires 2 operands, left and right. Both left and right operand are equal to the LHS part, right? So there is a possibility that you may expand this first or this first, right? If you expand this first, you get 1 tree. If you expand this first, you get another tree. It means there is a possibility that you may get 2 trees, 2 parse trees. Then it will lead to 2 different derivations, right? Which obviously results, in more than 2. So this is not recommended, right? This is not recommended. So it means this kind of grammar is not allowed in the programming language, right? So moving on to the next slide. If a grammar is allowing you to construct more than 1 parse tree for any statement, then the grammar is said to be ambiguous. Now, how we can make this grammar, which is ambiguous, from ambiguous to unambiguous? For example, so how we have transformed it, you can see we have replaced, this. We have replaced expression which is available as the right operand of that operation with term, and then term is further defined here as term by constant, and then term can be further defined as constant. So if I take this particular grammar, right, for the same constant minus constant by constant, you can see your parse tree will be derived like the expression minus term, because your expression minus term is the definition here, which you take. Then this expression can be derived to be term and then constant, because term is defined as constant, and then this term will be defined as term by constant, right? So then this term will be derived to be constant by constant. Can you see another tree for this? You don't find any other tree because you have expansion only from the left hand side, right? So this is how the grammar must be there while defining the grammar, the language designers must ensure that the grammar is unambiguous, right? Unambiguous, which can allow you to construct only one parse tree for any given statement, right? Okay, now coming to extended BNF here. BNF, you are given some denotations which you can probably use to compress the BNF statements and make it more beautiful, right? So here we have square brackets. You can see that the square bracket. So square brackets are being used to represent the optional parts. Okay, and square brackets are being used to represent the optional parts, and you have, if you have more than one, are the alternative parts, right? More than one parts which are being used, alternatively can be represented enclosed in parenthesis, separated with, vertical bar, right? And if you have certain terms, repeated 0 or more times, you can use this braces, right? So braces, parenthesis, and brackets. Brackets are being used to represent the optional parts. Parentheses are used to represent the alternative parts, and braces are used to represent the terms when are repeated 0 or more times. Okay. So moving on to the next slide, looking at the demonstration of this with the help of an example. So in this grammar, you can see expression is represented, is defined with 3 definitions: expression plus term, expression minus term, and you have term, right? So these 3 statements, right, is combined into a single statement. So how is it done? By using the EBNF notations, right? So expression defines to be single term as well. It can be just a term. So we have represented as term here. In the term which is available inside the braces, as you know that they will be used for 0 or more than one time. So here it means it can be 0 time. When this is 0 time, the expression is defined with this particular definition, that is expression as a term. But if it is being used for one time, then your definition will become like this: plus or minus term, right? So in this, the parenthesis being basically used to represent the alternative parts. Here you have 2 operators, plus or. You can use plus one time, okay, plus one time, and minus another time. So I got this definition and this definition as well, right? With the help of this, it means these 3 statements are being combined to a single statement. Similarly, you can see for the next, grammar, that is for term. So you can see term is defined to be term into factor, term by factor. We said then term can be defined as a simple factor as well, right? So these 3 statements are being combined into a single statement here again, right? So this braces, inside the braces, whatever you have, this can be used 0 time, or it can be 1 or more than 1 time, right? If I am using it for 0 time, the term will be defined as factor. If I am using this for 1 time, then my definition will become term within parenthesis into by into vertical bar by and factor, right? So this parenthesis is being used for alternate part. It means I can use into, or I can use by. If I use into, I get this definition, right? I get this definition, that is this one. And if I'm using by, I get another definition. So I am able to define all these with the help of a single statement. So EBNF will help you to compress the number of statements of the BNF grammar, right? Fine, moving on to the next slide. So the recent variations in EBNF took place, like, use a colon instead of this derive. We generally, when we were deriving, we were using this particular symbol, right? This particular arrow with two double lines. Okay, but in recent EBNF, what happens instead of this, we'll be using colon. It means when you are deriving the statement A, or say ID and all kind of things, you say colon, right? Colon A plus B, like that, right? And then for optional parts, we were using parentheses, right? Instead of that, enclosed parentheses separated with vertical bar, you can use optional. Okay. And for braces, you can use one of, okay, instead of that, right? There's some very recent development that took place in BNF, so you can use these notations as well while writing the EBNF grammar. Okay.